Hello guys, today we're looking at property of operations. Property of operations, or the properties of operations. And we have the cage. C stands for commutative property. And then A stands for associative property. J, I like to call it distributive property. But you know the real name for G is actually D, which is distributive property. But I prefer just to call it a given property. Given property. And then the E, we're looking at identity element. Is the element of identity. So this is the cage we're going to be working with today. So with commutative property, we jump straight into it. So with commutative property, we expect that if there's a number out of the 4 operations that we're going to deal with, let's make this addition, subtraction, division, multiplication. So we want the answers to be the same every time we run certain operations. So for example, if I have 2 and 3, and I add, yes, 2 to 3, will I get the same answer if I interchange them? Yes, I would. And by doing this, I've shown that addition is commutative. But what about associative property? So with associative property, we bring 3 plus 2. Let's add a third associate. Say plus 4. So we're running addition through the cage. So if we have 3 plus 2 computed first, before working out 4, what answer do we get? 3 plus 2, that gives us 5. When you add it, that gives you what? Add 4, that gives you 9. What about if we rather work the last 2 first before adding up? So if you work the last 2, that's 6 plus 3, that is 9. So see, the answers are the same on both sides. So addition is associative. Now, we go on to the given property. This is an interesting property. Now, we'll bring the same numbers down. This time, we change 1 to be a given number. This is the given number. We're giving it to what? We're giving it to this and this. Most of the time, we have a bracket to show the given property, or what I call give distributive property, or what you call distributive property. So if I give, how many times do I give? I'm going to give 2 times. So if I give individually, what do I get? I will get 3 times 2. If I have to give, I'd have to give, there's a 3 times, yes. So the given property will have to be given here and here. Now, if I work out 2 plus 4, which is 6, times 3, 6, 3, 18, will I get the same answer if I give 3? If I give 3 into the bracket, I'll get 6 plus 12, which is still 18. So this property of getting the same answer when you give to the terms is called distributive property. Now, identity element. So identity element, we're going to pick 3. And we're going to condense all this, or collapse all this. Yeah, so now identity element means that I want an element which is a mirror, which can create another element. So what element or what number can recreate, 3? What number can recreate 3 in addition? What number can recreate 3 using 3 itself? So if we want to add, there's a big question mark. If you want to add, what number can recreate 3? You can see that that number is 0. So 0 is the identity element for addition. Now, a twist on it too is this. There's an inverse element. We use the identity element to create the inverse. So I'll put the identity element here. So the question is, what number would I add onto 3 to give me the identity element? And that is negative 3. So negative 3 is the inverse, additive inverse. Additive inverse. So negative also means inverse, in this case, for addition. So that gives us the identity element. Back again, so the identity element simply reproduces the same element. Can you think of any other identity element? Yes. Leave me a comment to know what you think. Or you can create your own, use your own numbers to test whether addition is. And run through the 4 cages. Use your own numbers to test. Now, once you run a test of the commutative property, Yes. You realize that addition is commutative. Addition is also associative. Addition is having a given property. Also, addition has an identity element of 0. We can do the same for subtraction and test whether we will get similar answers. So for example, we can test whether it is commutative. Is subtraction commutative? 3 minus 4, or 4 minus 3 is 1. If you reverse it, 3 minus 4, you get negative 1. So this behavior means that subtraction is not closed. Same way, if you have 3 divided by 4, you get 1 point something. Now, if you have 4 divided by 3, 4 divided by 3, you get 1 point something. Now, if you have 3 divided by 4, you get something completely different. You get 0 point something. So it means that division is not having a commutative property. Both of these, division and subtraction, don't have the commutative property. What about multiplication? 3 times 4, 12. 4 times 3, 12. So this behavior shows commutative property. So multiplication is commutative. Now, what about subtraction when it comes to the 3, when it comes to associative property? So if you have negative, use only subtraction. So, and you work the first two associates. This is 4 minus 3, that's 1. Now 1 minus 2 is negative 1. Now if you work out, yes, if you work out 3 minus 2 first, okay, and that gives you what? That should give us 1. Now, if we work 4 minus 1, that should give us what? 3. So we notice also that subtraction is not associative. Yes, so we can also test for multiplication. We can test for multiplication. So that multiplication is associative. So again, 4 times 3 is 12. 12 times 2 is 24. And then you can still run 3 times 2 first, and that's 6, 6, 4, 24. So you see that multiplication is also associative. Then you can test for the other properties, and this is how you prove the various properties in terms of commutative property, associative property, distributive property, identity element. So remember the cage. All these operations can run through the cage, and these are the 4 properties that we demonstrate. So I mentioned that we'll have the live lesson, but in hindsight, I just thought I'll just do a quick video to help you capture these elements.